is having totally 5 modules, starting from this developing Azure compute solution, and the weightage for these 5 modules are exactly like this. To know about more details of this thing, you can go to the official site of AZ-204, and I'm giving you a surety that this course is following all the updated guidelines of this course. The agenda of the course is having total 13 modules, and in each module we are going to learn each and every concept with the practical hands-on, and we are going to see that how you understand each and everything with not only conceptual thing but also with the technical code and step by step doing those things with that. Microsoft Azure Cloud has a global footprint, and that's the reason when you're developing for this cloud, you have plenty of options to choose from. Across the globe, we have 58 regions available, and while developing your application, storages, databases and all, you can choose wherever you want to host your resources. That's the reason I strongly recommend that before joining this course, make sure you have successfully registered for your free Azure subscription, in which you'll get $200 of free Azure credit for 1 month, and those 30 days will be enough for you to prepare for the certification and as well as to clear the certification. With Azure subscription, I also recommend that you should have a Visual Studio 2019. You can still use the older versions like Visual Studio 2017 or maybe the free versions of Visual Studios which are available. If you're already good in handling Visual Studio, you can also use Visual Studio Code for this. But for this particular course, I am going to use Visual Studio 2019, and make sure that Azure SDK is installed inside your Visual Studio, because we are going to develop lots of applications and then we are going to deploy this thing on Azure. The first module of this particular course is focusing on app services. And app services are one of the coolest features of Azure because it is providing you pure platform as a service features on Azure. When you're dealing with web apps, mobile apps or any API apps on Azure, all these are counted as app service because it's coming under the umbrella of app services. Like a normal application, when you're deploying on any hosting provider, we have a server or a hosting plan. But in this case, in Azure, we have something called service plan. And your one service plan is going to have multiple applications hosted in that. We are going to see in this module how we can have one or more web apps associated with one service plan. And there are a couple of cool features which you are getting because of service plan and app services in Azure. You can integrate these applications with the tools like Visual Studio, Git, or maybe you're going to develop a DevOps pipeline with that. You can take the advantage of cloud and scale your application based on the customer load on that, and you can scale it vertically or horizontally. If you have multiple teams who are developing this project and you want to give a separate staging deployment for them, then we have multi-slot deployments also available. This application can have multiple instances running at the same time, and you can get the high availability of this thing across different regions using features like Azure Front Door. You can connect with existing SaaS platforms or maybe the data which is running on your on-premise servers. You can also take care of securities with respect to authentication and authorization. You can take care of this thing with either pure platform as a service model, or if you want to convert this thing into a serverless architecture, you can do that also. The monitoring of each and every data which is logged into this app service as well as the real-time live data is also available with the application insights. We have an internal local cache associated with app services, and also it has the web jobs to run this thing in background. We are going to see all this thing in action step by step practically in this module. To get an idea of an app service, I'm just taking you to my Azure portal, and as you can see on this homepage of this Azure portal, we have an app service which is associated with app service plan. I have a couple of resources hosted in this subscription. I'm just clicking on one of them, which is my app service with the name Chat with Maruti. I want you to notice that this app service is hosted on Central US region of my Azure. It is associated with this app service plan, which is on standard S1 plan, and then it has a URL which is some domain name .azurewebsites.net. If I click on that URL, I'll get a very basic application on that, and the output of this application is not important right now. What I want to focus is, if I focus on the left side section, we have a settings in which I can configure my application insights, which is coming under monitoring, authentication and authorization of this application. Maybe I have a purchased custom domain with me and I can associate this thing with that something.com domain instead of this default URL which is given by Azure. I can associate TLS or SSL kind of certificate settings in this. Or if I want to do scaling, as I said, a horizontal or vertical scaling, I can associate with my app service plan in that. The web jobs are also there. And if I scroll down a little bit more, you can see we have a separate section of app service plan. As we already discussed, one app service plan is going to have multiple web apps hosted on that. If I click on this app service plan, it will take me to that plan and I can see which applications are associated with that, and also I can monitor the CPU, memory and the data input usage of that. Azure portal is giving you all of this thing in one shot, and I hope you are familiar with the basics of Azure fundamentals. If you're not, I request you to go through my Azure fundamentals course first, and then you can go through this particular course, because this is focusing on AZ-204, and this is going to be purely created for developers who are going to work on cloud computing model with Azure. Okay, so it's a time to create our first resource on Azure portal, and obviously we are going to deploy our web app, which is nothing but an app service. So as we discussed, we have an app service plan on which the web app service is going to be hosted. Now on this Azure portal, I can click on create resource button and I can choose web app, and I can simply create a web app with app service plan. But before I do that thing, I just want you to see how we can deploy something on Azure portal through PowerShell. And that's the reason we are going to type shell.azure.com. Remember, if you have configured PowerShell in your subscription, then you'll directly get the PowerShell prompt like this. If not, then you'll get a prompt to create an Azure storage account which can associate with your subscription. If it is asking for that, you please proceed with that, and then you can fire a PowerShell script or command once you're getting this PS prompt. I have a PowerShell script open in my local machine which I have prepared for this lab. And now you can check here that this is my local PowerShell ISE. I will not execute the script here. I'll execute this thing on the Azure Cloud Shell only. You can get the Cloud Shell through portal directly by clicking on this button also. But when you click on this, it's going to give you a bottom bar where you have to execute the script in the small window. I prefer to do this thing in a full screen window like this, and that's the reason I'm opening this shell.azure.com. If we quickly check the PowerShell script, we have some variables on the top which are created with some GitHub repository URL, which is a sample given by Microsoft on this. A web app name is going to be unique, so I have a my web app, and with that I'm giving a random number associated by a command called getRandom. The resource group I'm keeping training RG1, and then the location for that we are choosing West Europe. Once we are done with this, these variables will be used at many places in this PowerShell script. And technically we are actually firing only 4 commands. New AZ resource group, which will create a new resource group on the specified location. New AZ app service plan, which will create an app service plan for me in the free trial. And then in the new AZ web app, which is actually going to create a new application in the specified service plan, resource group name. And then finally we are trying to just put all these properties inside a variable called $properties object, which later on going to be used in my final command, which is set AZ resource, which is going to set the resources for this project with respect to that GitHub repository and the branches which we have selected in this. If you want to use the script is available on this URL, which is pace.org 104467, and the same script I have shared for you so that you do not need to type all these things. You can directly copy the script from that and then you can paste this thing in this Cloud Shell. You can directly copy the script from this and then you can paste this thing in this Cloud Shell. It's showing me that resource group is created and the name of the resource group and the provisioning stage is succeeded. Now it's trying to create an app service plan for me. Within few seconds that is also done and it is created inside this resource group and this location. That's fine. And finally now it's creating a web app which is showing me a progress bar associated with that. It will take few moments and once the progress is done, I think new web app is also going to be created. When you do this kind of copy and paste of PowerShell script, it will always wait for you when you execute the last command. The last command in my PowerShell script is actually that set AZ resource, and you can see it's waiting for me to hit enter. I'm going to hit enter and then it's going to take this final command and it's going to set up all this thing based on the properties object which you have given. While this is doing this thing, we can parallelly go to our portal, click on resource groups, and hopefully you'll find a new resource group called training RG1. If I go inside that, I am going to have my app service plan and my app service inside that. You can see this is my app service plan and this is my app service inside that. If I go inside my app service, as you can see, this app service is showing me that it's hosted on this URL, which is the name of the app service.azurewebsites.net. I can click on this and it's going to open this site in a new window. Parallelly, we can see that it's associated with this free service plan and we can scale it anytime by clicking on the scale up. The location for this app is West Europe, and if I click on this new tab now, you can see that my application with the 3 different tabs are available. This is a very basic .NET based application and we directly took this thing from GitHub, so this is not a code which we have written, but yeah, we have a basic application ready for this. What I want you to focus is, if I click on Deployment Center, this app deployment is actually happened through the GitHub, and you can see it's showing me here that we have a source which is actually an external Git repository which is located on this particular URL. If you want to disconnect from this or if you want to deal with some other options, you can directly do it here. If I click on configuration, this is showing me my app settings and general settings available in this. Normally these settings you will find in your application code in your web config file or your app config file. It's showing me the different application settings. I can click on new application string and new connection string and I can configure all those things. Same way it's showing me the runtime stack and the version associated with that thing and which kind of platform I have configured for this. All this configuration your developers can customize whenever you want. Same way we have path mapping, we can add a new handlers for that, we can add a new virtual applications or directory for this, and all this configuration is just a click away. Just now, because we have deployed this application through this Cloud Shell, it happened step by step, and even the last step, which was set Azure resource, is also done. Now let's say you do not want to do this thing through PowerShell and you want to do this thing through Portal. You can click on Create Resource, choose a web app, provide your resource group. Because I have an existing resource group called Training RG1, I'm going to choose this. A resource group is a logical entity, and in one resource group you can have multiple resources hosted on that. My application name, I'm giving Maruti Portal app because this is going to be deployed through Portal, and I'm giving some number like 1, and it's asking me how you want to deploy your code. You want to do this thing directly as a code or you want to take it from a Docker container image. I'm choosing code right now, and in the runtime stack I'm going to select ASP.NET version 4.7. This is going to be an operating system based on Windows, and let's say I do not want to host this thing on the free app service plan which we already created. I have an existing service plan which is a standard S1 size, which is giving me a dedicated 100 Azure compute unit and 1.75 GB memory for that. Now let me choose this one. Remember, we are hosting this thing on the same resource group. The previous app was deployed on West Europe region, as we know from this particular screen. And this app I want to deploy on the Central US region. Now, can I deploy multiple resources on different regions within same resource group? Answer is obviously yes. And that's the reason we are doing this thing. If I click on next, we have monitoring section of this app, in which I am going to enable my application insight, and it's going to create one application insight also for this. We'll click on next for tags and review and create. Once this is done, we'll click on create button, and this will take few seconds to deploy this app service in that existing app service plan. You can see it's showing me that my deployment is underway, and while this is happening, it's actually taking care of all this thing through ARM template. Left side you can see we have a section called template, which is actually giving me a JSON template created for this deployment. And technically in this they are deploying two resources. One is an app service and the other one is my application insight. These two resources require 9 different parameters, and they are going to deploy all this thing in one shot. It's showing me my deployment is complete. I'm going to click on go to resource. This resource is in Central US, but still it is in same resource group, which is training RG1. And if I click on that, you'll get to know that this is the same resource group in which I have certain resources coming from West Europe and certain resources coming in Central US. Let's go back to that app, and this app is associated with the new service plan. Left side we have deployment center, and it's showing me that in this deployment center I do not have anything configured. If I want to configure an Azure CI/CD pipeline with Azure DevOps, we can do that thing, or I can associate any local Git or a repository from OneDrive or Dropbox kind of thing. So there are a couple of options available. We have not said anything because it's a dummy app which is created just right now with a basic structure. If I click on overview tab and if I click on the URL of this app, this is not having any code right now. It's just having a dummy HTML page given by Microsoft, and this young smart lady is developing on multiple programming languages at the same time. This page is a dummy page. If I want, I can download this publishing profile and I can publish my existing app which is developed in Visual Studio. We'll see this kind of things later on, but right now this application is deployed. And in this video we learn that how we can deploy application through Azure portal and how we can deploy app service plan and app services through PowerShell. So we are still with the same application which we have created in the previous video, and now it's the time to see some inside configuration and monitoring capabilities of this application. While creating this app through portal, I have enabled application insights. So make sure before you proceed with this, you have also done the same steps which I have followed in the previous video. Left side, if I focus on configuration and if I check at the right side part, we have an application setting, and by default I got a couple of configurations which are already there in my app config. If I want to do additional configuration of connection string with my databases, then I can click on new connection string. I can specify the name and value for that, and I can choose the type of that database also. Maybe I can connect with SQL Server because it's a .NET based website, and I can also enable a deployment slot settings. Normally when I checkmark this thing, a deployment slots are going to have an additional database association with that. What are the deployment slots? Well, actually depends on your service plan. If I go to my service plan, you can see that I have a service plan which is selected for dev and test, and production kind of tabs are there. If I click on dev and test, we have a free service plan, D1, B1 different kind of service plan. If I choose the free one, I do not have any additional features for my deployment slots. But the one which I have selected, which is S1 with 100 Azure compute units and 1.75 GB memory, this service plan is giving me additional features. Like I can have a staging slots up to 5 staging slots, and I can scale my application up to 10 instances. Left side we have a section which is deployment slots. It's showing me that I do not have any deployment slots right now. I have only one deployment slot, which is my actual production, which is associated with the actual URL of this application. If I want to add an deployment slot and I want to deploy applications on this, we can do that thing. Same way, if I click on scale out, this is actually associated with my scaling, where I can configure a manual or a custom auto scale with this. Other than this, if I click on authentication and authorization of this application, by default right now anonymous access is enabled for this application, so technically we do not have any authentication and authorization mechanism. To configure authentication, I can click on and I can give an open authentication with websites like Microsoft, Facebook, Google and all. And all I need to do is I just need to click on that configuration. I need to provide an app ID and app secret from Facebook, which you can directly click on this and it will navigate to developers.facebook.com, and you have to register your application for different kind of authorizations which you want to give. The scope which you select here is going to give that kind of rights for that application. If I choose Azure Active Directory, I can go to my Azure AD and the users of my Azure Active Directory with that specific tenant can access my application things. This all configurations we can see later on when we focus on the security part of my application. Other than this, we have a monitoring capabilities given in Application Insights. If I click on Application Insight, because this is enabled, you can see here, we have an Application Insight for this one. I can see the data of Application Insight by clicking on this link, and this will take me to Application Insight of the same app. You can check here, it's showing me all the live data associated with this thing, and it's taking these things with that. Left side we have something called live metrics, smart detection. All these tools are useful when your application is getting some issues and you want to keep track of that. Within few seconds this live metrics will be ready and it's going to show me a live data associated with my application. It's not showing me anything because maybe nobody is using my application right now. I have my application open in a separate tab, and let's say if I am going to hit couple of requests here and I'm going to just refresh my page couple of times, and if I come back to this particular live metrics, within few seconds I am going to get the details about that. Now as you can see, it started responding this thing in that, and because I did 2 requests in that, it's giving me that request associated with that. Any application load, any fault or any error which is happening into that, you can keep track of overall health of this application in this one single screen. And as we know, all these facilities are available to us as a platform as a service in this Azure App Service. Your app service is hosted on App Service Plan, and this App Service Plan is actually scalable. You can see we have 2 options here, scale up and scale out. And these 2 words are actually associated with the term called vertical scaling and horizontal scaling. Remember, in all the Azure resources, if it is app service, virtual machine or storage services, we have a scaling facility available in that. When we talk about scale which is vertical, it is always about increasing the capacity of the running instance. Now what I mean by that, suppose if I choose S1, which is having 100 Azure compute unit and 1.75 GB memory allocated for my app service plan. And if I decide that I want to go for the premium one, I'll get the higher capacity of this. Or if I decide that I'm going to go with the lower one, let's say if I'm choosing D1, then I'm going to have 1 GB memory only associated with this thing. So it's something like this. I'm downgrading this capacity of this service plan from S1 to D1. Or maybe I can go with the free plan, which is just giving me a shared infrastructure with 1 GB memory. Now the moment I choose any of this plan, this is actually showing me that I can scale this up or down. In short, I can increase the capacity and the compute associated with that. And obviously the cost which is associated with this service plan will change based on that. Now this is also adding and removing features which are associated with customized deployment or a hardware. When you're dealing with this thing, this is something which is known as vertical scaling, because it's just dealing with the one single running instance and increasing and decreasing the capacity of that. While in other case, if I click on scale out is all about horizontal scaling. You have an option to configure horizontal scaling by manual scale, and depends upon your service plan which you have selected. You will have number of instance count which you can increase and decrease. Because we have selected S1, we have up to 10 instances which we can configure in this. If I specify 2 instances right now, and after that if I just change it to save, it's going to create 2 different instances of my app service plan running in this. Other than this, if you want to configure an auto scale, you can just click on this, and then you have to set a rule for that. If I click on add rule, in this new blade, I have to configure which kind of criteria I want to measure. Let's say the metric which I want to measure is a CPU percentage. And I am saying that if my CPU percentage is having a threshold of more than 80%, so it's every time when my CPU is hitting 80%, so more than 80% for a duration of 10 minutes. If the CPU usage is more than 80% for the duration of 10 minutes, this is that particular condition which I want to add. The moment I do this thing, I also want to configure that the minimum instance will be 1, while I do not want to go more than 7 instances. And the default is also going to be 1. The moment I do this, and if I click on save, this auto scale configuration will be applicable on my instance. And if the load of my application increase, and if CPU is reaching to more than 80% limit, automatically Azure is going to take care of 1 instance increment into that. This is something which is a horizontal scaling, where you are going to have multiple instances running at the same time. Okay, so we are still with our same app service which we have deployed through Portal, and I have a URL of this app service which is open in a separate tab. This app service URL is this name.azurewebsites.net, which is having this dummy page on that. Now let's say I have a team of developers who's working on this application, and they are working with Visual Studio, and they have to deploy this application on Azure. When they want to deploy this thing, I do not advise them that they're going to directly deploy on this actual URL, which is my production. So it is advisable they go to deployment slots, and I am going to provide a separate slot for them. Let's say I'm adding a new slot, and I'm giving a name of this staging slot. I can add multiple staging slots, so I'm giving staging slot 1. And then do I need to clone any settings from the existing application? Right now I do not want, so I'm going to click on add. The moment we do this thing, this is going to add a new staging slot with the temporary URL dedicatedly assigned to this. That URL and the configuration of that URL will be totally separate from the actual production. You can provide the details of that URL with the FTP credentials and all to your developers, and they can associate this staging slot separately with the Visual Studio. My staging slot is created. I'm just going to click on close, and you can see this staging slot is having a separate URL given here. The traffic of this application is 100% given to my production only. If I want, I can even distribute some partial traffic to this staging slot. Let me click on the staging slot, and this looks like a normal app service only, because this is also an app service where we can have a separate deployment. This is also associated on the same app service plan, so performance wise I'll get the same performance. Let me click on this URL, and this is a separate URL with the name -staging slot1.azurewebsites.net. So this is the name of my staging slot associated with that app service. And now this staging slot I will give to my developers. I'm going to click on this link, which is get published profile, and it's going to give me a full published profile with the XML configuration associated with this slot. This profile will be helpful for my developers when they associate this thing to my Visual Studio. Let me open my Visual Studio 2019, and we are going to develop one basic .NET based application in that. I'm going to click on create a new project, selecting ASP.NET application, and then I'm going to click on next. The name of the application is Web Application 111. We are okay with that. And the .NET Framework 4.7 is there. We are okay with that also. I'm selecting MVC as an application template form. If I want to choose, I can choose a Web API also. It's ultimately the same thing. Do I need to configure any authentication in this right now? No, I do not want that thing. Everything else is fine. We'll just click on create. I'm creating a very basic MVC application in my Visual Studio, and once this application is created, the code of this application will be in my local machine inside the Visual Studio itself. The goal is that application code now we want to push to this staging slot, and as we know that in the staging slot we have that dummy page with that image. Instead of that, we are going to push this code from Visual Studio into that. Yes, my application is created inside Visual Studio, and right now if I try to run this application, this is going to run on local IIS. If I just quickly run this thing to check whether it's not having any issues in that, my application is loaded in the browser, and you can check this is running on localhost and some port number. It's just a basic application with home, about, contact kind of tabs, which is the default template of my MVC based application. If I go back to my Visual Studio, I have folders like models, controllers, and views because this is an MVC application with some web configuration and global.asx. I'm not going into the core of this application right now, but let me right click on this application, and there is an option for publish. When we click on publish, Visual Studio allows me to publish this application either as a normal app service, and I can create a new app service, or I can choose an existing app service also. If I want to go for a deployment which is not a PaaS but infrastructure as a service, I can also deploy this application directly onto my Azure virtual machines. What I'm going to choose right now is I'm going to choose app service, but in that I'm going to choose import profile because I already have a profile downloaded from my portal. I'll click on downloads and I'll select my profile which I have downloaded from that. This is my profile of staging slot 1, and I'm going to click on publish. This will take some time and is going to publish this full code into that particular staging profile. When you deploy through this first time, it's going to take some time because it's going to deploy full project into that. Second time onwards, it's just going to take all the changes which you're doing in your code and it's going to quickly push that thing to that deployment slot. Now if I go back to my portal, and I can check that my staging slot is actually having this application deployed. Now let me go to deployment slots and assume that my testing team has already tested everything on staging slot, and now this staging slot is ready for move to production. The production is okay, this is a production URL. If I refresh this, this is still having that same dummy page, and this is a staging slot URL. If I refresh this, this is going to have my new application code in that. Now inside Azure, we have a facility which called swap. When we click on swap, we can swap from any slot to any other slot. Like I can choose that right now, my source is my staging slot, and from that I want to swap to a target one, which is my production. If I click on swap, this will take some time and this will swap my staging slot to production and my production slot to staging. Technically, this is just going to do a URL rewriting internally and is going to perform the swap so that immediately the code which is there in your staging slot will be swapped to the actual production URL, and your customers will get immediate effect on that code. The moment this is done, your dummy page which was available on your actual production is actually going to be shifted to the staging slot. For the safety purpose, they do this thing because after even swap, if you have any issues in your production environment, then you can quickly swap that thing in the reverse back, and then you can take care of those things. My swap is successfully done. I'm going to click on close. Still production is running, staging slot is running. We'll go to our staging slot and we'll click on refresh. It has a dummy page now. We'll go to actual production URL and we'll click on refresh. and now this is going to have my application code. Now assume that if something goes wrong with this code at that time, you can again go back to this and you can swap to the previous one, do all the remaining testing which is there, and you can deal with that. Additionally, if you want to check the logs of this, you can click on logs and you can see the detailed logs associated with that particular swap which is just now happened with that. Alright, so now it's the time to learn Azure Functions. Azure Functions are allowing you to write your piece of code as a function on cloud, which can run independently in a stateless environment. Azure Functions are actually part of serverless computing if you choose to run this thing as a consumption plan. To deal with Azure Function, we have two different flavors. A platform as a service, if you're choosing app service plan which you already have, or if you're going with the function as a service, then you can choose this thing as a serverless, in which Azure is going to allocate a computing whenever you're going to execute the Azure function. And this is something which is one of the cost effectiveness, because you do not need to pay for any compute which is continuously allocated to that function. You only need to pay for the execution time whenever your function is actually executed. Azure Functions are actually going to provide an open source web job code. Now, if you are familiar with web jobs and if you deal with web jobs in Azure App Services, then let me tell you one thing. Azure Functions are also associated with web jobs code only, but the only thing is these functions will be totally independent and it can be integrated with any existing Azure resources. It supports for a wide variety of programming languages, including C#, Java, PHP, Python, JavaScript and all. If you are not a developer and if you are an administrator and if you want to write some piece of logical things in a PowerShell or shell scripting, that is also allowed in Azure Functions. In short, if I have to explain this thing in one line, this is the cheapest way to execute your code on Microsoft Azure Cloud. Azure Functions can literally connect with almost everything on Azure. If you want to connect this thing with Azure storages, with table, blobs or queues, you can do that thing. If you want to connect this thing with any kind of event triggers like Notification Hub, Event Grid and Event Hubs, you can do that thing. Azure Functions works on triggers, and that's the reason most of the time the piece of logic which you have written inside Azure Function is going to get triggered by some existing event. It can be a new file which you have uploaded into your blob storage, or maybe a new record which is inserted just now in Cosmos DB. You can associate Azure Function with almost all the resources of Azure, as well as there is an important section in which you can configure an alerts also which are based on Azure Functions. So when an alert is getting triggered with that is going to execute the piece of logic which is written inside Azure Function. There are a couple of things which I want you to keep in mind when we are dealing with Azure Functions. Remember, functions are based on triggers, and that's why you can trigger them either from a blob, Cosmos DB, service bus, message queuing, or maybe it's a timer trigger based schedule function where you can configure that every certain period of time is going to get executed again and again. You should keep in mind that you should avoid long running functions, because when you go with the consumption plan, Microsoft is going to give you a 10 minutes timeout. It means if your function is running for 10 long minutes, at the time of 10 minutes timeout, it will get terminated. Same way, if you are dealing with any HTTP request and using the HTTP request, if you are doing request and response, then the timeout will be reduced to only 2.5 seconds. You have to remember that use queues for cross-function communication. We have a concept called durable function which I will cover later on in this course, and if you're dealing with the function-to-function communication, durable functions are really easier one, or you can go with something called Azure Logic App, which is also a part of a serverless computing. Always try to write a stateless function, because these are going to be an idempotent and a stateless function, or I can say a piece of code which is going to be helping you in your number of requirements. Lastly, I strongly recommend you to go through this GitHub repository where you will find number of samples on Azure Function host. Once you're familiar with these basics, let's have a look at this Azure Function app and Azure Function inside that in action. Okay, so it's the time to create our first function app through Azure portal, and I'm going to click on create resource, and we have function app here. I'm creating a new resource group, and inside that we'll deploy this. The name of the function app, let's say I'm giving Maruti first func app 1, and that's fine. We'll publish through code. Runtime stack here has a couple of options. As we discussed in the previous video, we have different options available here. We have .NET Core, which means C#, Node.js is for JavaScript, Python, Java, and PowerShell is also there. Let's choose .NET Core so that we can get the C# code in that. And then in the version, we are choosing 3.1. The region which is associated with this thing, let's choose Central US only. We are okay with that, and we'll click on next. The moment I click on next, you can see it's showing me that to store the code, the piece of code which you're going to write inside your functions, to store that code, you need to associate this thing with the storage account. You can choose your existing storage account if you have, or in my case, I'm creating new one. Which kind of operating system you want to use while hosting these functions? I am choosing Windows. And then here is that particular drop down, which is making sure that this one is going to be serverless. Now, if I choose consumption plan, it's going to cost me only when I execute my function. And this costing will be based on the time of that execution, which is already occupied by that particular code. Now, if I choose consumption, technically, I do not need to pay any amount until unless I execute that thing. And suppose if I go with app service plan, it's something like this, that if I have any existing app service plan, I can choose that thing. And in that case, because I'm already having an app service plan, technically function app will be free because it's not going to cost me anything extra even if I run functions inside that. If you want to go with the premium one and you want really high compute with this, you can go with the premium and you can choose a dedicated compute for your function app. But in my case, I'm choosing consumption so that it's going to be based on the execution. Do we need monitoring right now? No, we do not want to do monitoring right now. We'll move forward and we'll click on create. Remember, the thing which we are creating right now is a function app, and one function app can have multiple functions inside that. So number of functions will be more inside this. You can have as many number of functions you want to create in this, but all these functions will follow the same runtime stack, which is .NET Core 3.1. Okay, my function app is deployed. Let's click on go to resource. And inside this is going to show me that I have functions, proxies, and slots. There are three kind of things are there. Inside the functions, I will surely not have any function right now. So the first thing which I'm going to do is I'm going to click on this plus icon. It's asking me how would you like to create a function. You want to use Visual Studio, you want to use Visual Studio Code, or you want to go with the in-portal editor. Now, if you do not want to use any of these tools, you can go with in-portal. And literally you can write your code, test your code, and you can see the logs associated with that within the portal itself. Not only that, Microsoft is also giving you a couple of ready-made templates available here. As we know that Azure Functions works with the triggers, and every time the execution of the code will happen on the particular trigger. By default, right now we have two different templates, which is webhook plus API and timer. And if I click on more templates, we have more than 30 plus templates available within the portal itself. Let me click on webhook plus API, and this will going to be like a normal REST-based API where I can deal with the get, post, put, delete operations with HTTP. I'm going to click on create. My function is created, and you can see this is a function which is HTTP trigger 1 function inside this list of functions. And it's having some basic C# code inside this. As you can check, we have libraries which are coming from .NET Core, and also we have some libraries which are NuGet packages, as well as system.NET, which is a .NET library. We can use .NET, .NET Core, or any NuGet package which is based on C# into this particular code. We have a very simple asynchronous task created inside this, which is having a name run. And every time when this function is getting triggered, it's going to execute this function and it's going to call this run method inside that. This run method is trying to get the values from my query string, and the name of the parameter associated with that is name. And if I'm passing any name, it's simply going to print hello plus that name, or if I'm not passing anything, then it's going to print, please pass a name in the query string or in the request body. So this is a very basic hello world kind of sample which they have given us. The thing which I want you to understand is exactly below this section we have logs and console. Or your function is getting called with the help of trigger, then this logs are going to show you, then this log window is going to show you all the logs here. Same way, if I scroll at right side, we have a section which is for view files and taste. This view files is very much similar to your solution explorer of your Visual Studio, where it's showing you all the files. You can add new files, you can have multiple C# files, and the extension of the C# files will be CSX. Do not get confused with the extension because this is pure C# only. The configuration of function is done by function.json file. If you check on this left side, the function.json file is telling me that this is a function which is HTTP triggered, and it can do get and post kind of operations in this. Also, if any other parameters are associated with this function, we can define this here. Every time when you change the template of the function, or while creating a function from portal, if you choose a particular template, this function.json file configuration will get changed based on the template. Right now, let's see whether this function is running or not. Let's click on this URL, which is get function URL. We have a full URL associated with that. Let me copy this URL, and in a separate tab of my browser, if I directly hit this URL, it's showing me please pass a name or a query string or a request body. Now I need to pass a name. Now if you notice this URL, it's already having one query string parameter, which is code, which is nothing but a unique token for authentication. I am passing one more parameter in this using ampersand, and I'm saying the name which I want to pass is Mental Stack, which is the name of our website. And if I hit enter, it's going to show me hello Mental Stack. Now this is something which is telling me that just now when I have pasted this URL in the browser, and if I'm hitting enter in that, I am actually executing this function twice. And logically I have to pay for only 2 executions right now. Immediately the moment your code is working and the function is getting triggered, you can utilize this thing. Same way, if I click on this plus, I have plenty of templates available in this, in which I have a normal Azure functions, and as well as we have something called durable functions also. Like you can see, I have a functions which are queue storage triggered, we have Azure blob storage triggered functions, we have Cosmos DB triggered functions. Now let's say right now I do not have any Cosmos DB in this account, but if I scroll up, we have something called blob storage triggered. And we know that when we created this function app, it was creating one storage account also with this. So I know that there is a storage account which is associated with this function app, and let me configure a blob storage trigger function now. If I click on this, it's going to ask me that what will be the name of that function, and then which kind of path you're looking for. A name of the function by default is blob triggered one. I'm okay with that. And it is asking me that which kind of path you're looking for. Now this path will be the name of the container with which you want to associate. Whatever name by default they have given, I can change it, but I'm not changing it. I'm just copying this name so that I can use it somewhere. And then the name of the connection string while creating and connection with the storage account, it will be this one. So I'm okay with that. We'll click on create, and then it's going to create a new function now inside the same function app. So you can see one function app can have multiple functions. The first one was HTTP trigger, and this one is a blob triggered one. It's just having one line inside this, is having a run method inside which we have parameters which are taking that blob and then printing the name of the blob with the size of the blob. And if I just move it right side, you can see that this time also in the view files we have run.csx file and we have function.json file. But this time the configuration of this function.json file will be different. Because this is not an HTTP triggered, we do not have something like get, post and all. Instead of that, we have a type of the function which is blob triggered, and the path of that function which is sample-work items. That's the name of the container which it is looking for. This is showing me that if I change my function.json file, then it's going to change the way the execution of this function is going to happen. To check whether this is working or not, I need to check one thing. I'm just going to click on integrate at the left side panel. And if I expand the documentation section, it's going to show me that the storage account which is connected with this function app is actually storage account train B031. Okay, so I want to go into the storage account and I want to do something with that. Let me open a resource groups in the new tab. So I'm keeping my one tab open in the browser, which is actually having this function. Also, let's do one thing. Up to this point, we have not triggered this function anytime, and I'm just keeping this logs open here. In the separate tab, I'm going inside my resource group, training RG, and then inside that, I'm just looking at this storage account, which is storage account train B031. Inside that, we have storage explorers, in which we can create containers, tables, file shares, and all. I'm going to right click on this, and I'm going to say I want to create a new blob container. Let me give a name of the blob container, which will be exactly same what I have copied from that sample-work items. The access level for this, let's say I'm giving container level access, and then I'm going to click on create. If you're not familiar with storage account, just go through my Azure fundamental course. Otherwise, in the same course also, after one module, we'll focus on the storage accounts. If I expand, I have a sample-work items. This is that container, and my function is continuously looking for this particular container. Let me upload one file into this. So I'm going to click on upload. We'll choose one of the file from our machine. I'm choosing one of the file, and then I'm going to say overwrite this file if it's already there, and click on upload. The moment we upload this thing, the size of the file is around 2 MB, and then the moment we upload this thing, automatically this is a moment when my Azure function is going to get triggered, because we have created function which is a blob trigger function. So the moment this is getting uploaded into this, immediately I want to switch to my function app, and I just want to wait here. Now you can see the moment I came to this function app, it's showing me that okay, you have uploaded one file which is with this name, and the size of that file is actually this one. So this name and size which we are printing into this, they are just triggering that function, and they are printing this thing here. Now this is showing me that my Azure function can technically connect with almost anything on Azure, and it has a couple of triggers associated with that thing. I hope you understood this. Thank you. Okay, now it's the time to deal with Azure storage accounts, and especially Azure Blob Storage. When I click on create resource, and if I click on storage, you'll get to know that I have a storage account, which is simply telling me that it can store blob files, tables, and queues. Ultimately, one storage account is going to have this 4 flavors of data which I can store in that. If I click on the storage account, inside that we have 3 types of storage available. Let's say I'm specifying that I'm going to create a new resource group with the name training RG, and then I'm going to give a storage account name. I'm giving a name of this thing Maruti Storage ACC123. It's a storage account which I'm creating right now, and saying that's already there. Then let me create something which is 1. After this, in the location I am choosing East US, and after that in the performance we have 2 options, standard and premium. Now before I proceed to any other sections, I want you to focus on this section where we have account kind, and this is what a type of storage means. When I click on this drop down, we have 3 options. We have general purpose V1, general purpose V2, and we have blob storage. If I choose either V1 or V2, I will have table, files, blobs, and queues, all 4 options available in that. But sometimes clients wants to use only a blob storage, then they can choose blob storage, and in that case they'll be able to store only in the form of blobs. When we are focusing on blob, we have something which is a replication and access style. The replication of this particular storage is giving me 3 options in that: LRS, GRS, and RAGRS. In LRS, we are going to have multiple copies of your blob storage locally. Most of the time it's going to have one geo-replication based region, and in that we are going to have multiple copies stored in a separate racks of the data center, so that if any power failure kind of things happen, I can get the availability associated with that. In GRS, we are going to have geographical copies across multiple regions. But out of these 3 copies, you are able to access only 1. And then in RAGRS, we are able to access geographical copies across the globe, and out of 3 copies of GRS, we are able to access 2 copies. One, which is a primary copy, we can do read and write, while the secondary copy, we can do only read. If I choose RAGRS, it's going to show me that account with the selected kind, replication and performance type only support block and append blobs. Page blobs, file share, tables, and queues will not be available in this. Now this also adds one more thing, that when you're dealing with blobs, we have three kind of blobs in this. We have block blobs, append blobs, and page blobs. To understand this thing, let's see one slide. One blob storage account is going to have this kind of three kind of blobs. Block blobs are actually composed of blocks of different sizes that can be uploaded independently and in parallel also. This kind of blobs involves mostly an images and videos kind of files into that. The append blobs are specialized block blobs that are supported only in appending new data. Most of the time when we are storing something like logs and all, or a streaming data, we do not want to update or delete the existing data, we just want to append the new data into the existing one. And that's where append blobs are useful. The third type is page blobs, are designed for scenarios that involve random access reads. And in this case, which data you're going to access, that's not predefined. Randomly you can access this thing. Most of the time we store a virtual hard disk kind of data into this. So these are the three different types of blob storages which are available. Now as we know in the screen, if I choose blob storage right now with RHGRS, it's going to tell me that I cannot store an page blob, file share, tables and queues in this. In my case, I'm choosing storage v2, and the moment I do that, it's going to show me that okay, now you do not have that restrictions, you can deal with table, blobs, files, queues as well as all three kind of blobs also. I'm choosing this. Below that we have something called access tier. This access tier is having association with something called storage lifecycle. And remember, in this access tier, we have association only with the blobs. You can see in this alert that they are saying that the access tiers are associated with the blob levels actually. And basically we have three kind of access tiers. We have hot, cool and archived. Now normally hot is actually that access tier which is allowing you to get the frequent data access as fast as possible. If you have a data which you're going to access frequently, then you have to choose your access tier as hot. Suppose you have a data which is not frequently accessible, but you want to store a huge amount of data and somehow you want to associate cost with this. If you choose cool, cost wise, cool will be cheaper than hot, but performance wise it's going to be not that good compared to hot tier. Also after this we have one more stage of the life cycle which is known as archived. I will explain the life cycle of the storage account and the blob storage account separately in the video in this course. Right now we know that we have a storage account creation like this. We are choosing v2 and we are specifying RHGRS. While creating this thing, I am choosing the access tier. The default access tier for this is going to be hot. In the networking section, we are going to allow this thing to public endpoint. I do not want any secure transfer required in this, and I'm going to click on create. Deployment of my storage account is completed and I'm going to click on go to resource. I want you to notice a couple of things. You can see that my performance and the access tier is standard as well as the hot. And then because I have chosen RAGRS, it is showing me that the location of my storage account is not only one which is East US, it is also showing me a secondary region which is West US also available. And that's what RAGRS means. So I have a global geographical replication and that is coming from East US region, West US region both. And then in that also, because I have done read access, it is allowing me to get the data as a readable format from a secondary region. And that's what which is West US. One storage is divided into 4 parts, and especially this is v2. So we have containers which are actually allowing me to store blob data, file shares, tables and queues. To access a storage account, you always need to access this thing through access keys. And that's the reason left side we have a section called access keys in which it is showing me my storage account name, and below that we have 2 different access keys given to us. We also have a connection strings created based on both the keys. Anytime if you want to regenerate these keys, you can just click on this and you can regenerate your keys and the older keys will not be valid. If you want that your storage blobs, tables, files or queues is going to get access inside any particular existing application, or if you are a developer and you want to develop code which is going to allow you to store data in Azure storage account, you have to use these keys and connect your application using that. We will see this in depth in coming videos. Thank you. Alright, so now I am inside my storage account which I have created in the previous video. This is the same storage account which is having a hot access style, and now it's the time to understand lifecycle management of a storage account. Remember, we know that we have three kind of storage accounts: version 1, version 2 and blob storage account. Left side, inside this version 2 storage account, if I scroll down, I have a section for blob services, and remember, all the services are only associated with the blobs, so it's not applicable on files, tables and queues. If I click on lifecycle management, for all the blob files which are inside general purpose v2 account and a blob storage account, this lifecycle rules are going to be applicable. You can see I do not have any rules right now, and I can add a rule. Now, to understand this lifecycle, you have to understand that in a blob lifecycle, we have total 4 stages. You assume like this, that like a human lifecycle, when we get birth, after that we have couple of stages which we live throughout the life of the human. Same way, when your storage account is going to have any data inside that, in the beginning, the data will be hot. Because while creating the storage account, I have set the default access style for that is hot. If I'm not using that data over a period of time, then it's not a point keeping the data always hot and always accessible. Because if I keep the data hot, then it's going to cost me more. It is advisable thing that you decide a life cycle of your data based on your kind of customized rules. Like, I'm clicking on add rule, and then I am specifying that this is my blob rule 1. I am going to check mark this 3 check boxes. Now I'm specifying that if my data is not changed, is not modified in last 10 days. Now you can check, this is a property which is saying that days after last modification. So I'm specifying that if my data is not changed in last 10 days, I want to move my blob to a cool storage. So my blob storage is now going to be shifted to a cool storage. And those files will be shifted in a cool storage, so that is not going to cost me much. Suppose if I am going to access any file within the 10 days duration, then that file will remain hot. Same way, let's say the data is shifted to cool. And now you are still not using the data for another 40 days. So if the data is in a cool stage and for another 40 days, you are not specifying that thing. So it's saying days after last modification. Now this also means that last modification means these dates are already part of this 10. So this is counting that last time when you modified the file. From that, if it is 40 days older now, it means this 10 plus another 30. Then we are going to move this blob to archive storage. When the blob is moved to archive, it will still be accessible but not immediately. It will take some time when you try to access the archive blob files. And suppose after this, I am specifying that if I upload any blob file and then let's say for 365 days, it means almost for 1 year, if I'm not using that file, then I'm going to delete that thing, because obviously this file which I have uploaded, and if I'm not using this thing for 1 year, then maybe this is useless file. When I'm doing this thing, we also have a rule for snapshot. Remember, Azure always create a snapshot which are kind of a point in time backup of the data. If you want to get any file from the snapshot, you can do that thing. And we can set a rule also for that, that if I want to delete a snapshot after a couple of days, we can do that. Now this customization is totally in your hand. Suppose if I do not want to go for a delete blob kind of option, I can just uncheck this. And if I uncheck this thing, my life cycle of the storage is defined only up to archive. It means after 40 days, my file will be shifted into archive and it will never be deleted. It means if I want to access this thing later on, it will be available after some delay. Same way, if I move forward to next, we have a filter set. We can specify the filter set and we can give a specific path of the container. Now we do not have any containers right now inside this, but when you go to store blob, if you want to define a rules for a specific containers only, then you can specify the path and you can give a name of the container here. Whichever path which is associated with this will have that rule. After this, we are specifying next, review and add. And then if I click on add, this is internally going to generate an JSON configuration for me. That's the reason when I do this thing, you can see we have one more tab which is known as code view. When I click on code view, it's going to show me the same configuration which I have done in the JSON configuration. If you want, you can directly change this also later on, or you can have a set of rules available in this by clicking on this add rule. I hope you're getting this lifecycle management, which starts with hot, then it moves to cool, then it moves to archive, and then it moves to delete. Thank you. Alright, we are still with the same account, and let's say now it's the time we want to create one application which will have some code, and that application is going to allow me to push some data into my Azure blob storage. To do that thing, first I'm going inside my container section, and I do not have any containers inside this, so let me create a new one. I'm adding a new container called images, and let's say the access level for this we are giving containers, and then I'm going to click on create. The moment I do this thing, this new container will allow me to upload multiple images into this. So I can go inside that and I can click on upload, and I can upload multiple images into this. But I do not want to upload images directly from this portal. I want that somewhere I should have my application, and through the code of that application I can upload things into this. To understand this thing, we need to use Azure Storage APIs, and to do that thing I have one sample which I have created and I have shared with you in this repository. So for you also, if you just go to github.com/trainermaruti/this storage blob upload from web app, this is a web application code which I have associated with the storage blob. I request you to click on the fork of this repository once you go there, and if you have a GitHub account, this will automatically fork into that. You'll have access of this GitHub repository connected with your GitHub repository, and then you can just click on clone or download, and you'll have an option association with Visual Studio. Remember, if you do not sign in with your GitHub account, you will not have this middle option. You will have only the options like open in desktop and download zip. That will also work if you download this manually first and then you associate that thing with your Visual Studio. In any ways, I'm going to click on open in Visual Studio because I have connected with my GitHub repository. You can see it's showing me that you can connect this thing with the local Git repository. Do you want to clone this? I'm saying yes, clone this thing, and it's going to create a new storage repos with this particular name. I'm okay with that. I'm going to click on clone. It's going to take all the files from that repository and it will give me a local Git repository association with that. Yes. Once it is done, inside this folder we have a solution file. This image resize web app.sln is actually a solution file of my MVC web application project, which I have coded inside this. I double clicked on that, and now I'm inside that web app, which is having a folders like models, views, controllers and all. Make sure inside the dependencies you're not getting any yellow mark. If you're getting any yellow marks in this, just build your application once to make sure that you're not getting any errors. For me, build is succeeded. It means my application and the libraries which are associated with that is proper. Inside the Solution Explorer, I am first going to hit this section which is app-settings.json. In this app-settings.json, I have an association with my existing blob storage account. And then we have an older account key. I want you to change this thing with respect to your storage account name and the account key. You can go to your portal. Inside this storage account, left side you have a section called access keys, and that's the place where you have a storage account name and keys. Let me copy the storage account name first, and in my Visual Studio I'm going to paste it here. Same way I'm going to copy this key 1, and inside my Visual Studio I'm going to replace it with the account key. I'm going to save this file, and now let me show you what kind of sections and code I have in this application. Once this is associated, remember we are connecting this application with that storage account. Other than this, I do not want to change anything. I have a models folder inside which I have a very simple C# class which is just associating with the account name and account key which we have provided in that configuration. With that, I have one image container property also which I am using in this application code. Somewhere inside the controller of this application, we have images controller which is working like an API. And then inside this we have two methods. One is allowing me to upload images into this, while the other one is allowing me to get thumbnails from that. Both of these methods are having a C# code in which we are trying to associate with the APIs associated with this class called image resizer web app.helpers. Now these helpers are also part of this project, and inside that we have a storage helper.cs in which I'm trying to use azure.storage.blobs. This is that main library which is helping me to connect with the storage and dealing with the storage to get the things from that. You can go through this code and you can understand the C# part of that. If you need any help in this, you can message me or email me anytime from the contact section of the MentorsTech website. Right now we want to publish this and we want to see whether this is working fine or not. So let me right click on this and I'm going to click on publish. How would you like to publish? I'm going to click on app service, and let's say we are going to create a new app service. It's going to give me a default name of that app. It's giving me image resizer web app. I'm just adding a name here, image resizer web app Maruti 1. I request you also change and put your name there so that it's going to be unique. My subscription is like this. In the resource group, I'm choosing training RG resource group, and obviously the hosting plan for that is going to be the existing hosting plan which I already have. Once I'm done with this, I do not want the application inside, so it is none, and then we'll click on create. On the publish tab of this deployment wizard, all we need to do is we need to click on publish. This will take some time and then it's going to get published on my Azure portal. Okay, now it's showing me that my application is successfully deployed on this URL. Within some time it's going to just restart my web app and it's going to take me to that particular browser page. Or parallelly, I can also go there, and as we can see, our application is there, which is also having this upload photos kind of section, and we have a list of photos also. Let me upload one image from my machine. From my pictures, I'm just going to upload one simple image. And you can see that the moment this image is uploaded, we are also displaying this image below that. It will upload that image, and as well as is going to create a carousel here which will show me a second image also. Anytime I can click on this and I can change the image, and actually both of these images are uploaded into that blob. So if I quickly go to my storage account, in which if I click on overview and let's go inside a containers and that images. When we go there, we have these two images which we have just now uploaded into this particular container. Uploaded image, and also is trying to get the image from this one. I hope you understood the sample, and I request you to go through the codes of that. Thank you. Okay, so we are still with the storage account, and we have 3 containers. Now inside each container I have 111 image, and we have access keys, in which I have already shown you that we have 2 different access keys already available in this. And these 2 access keys are going to help you when you want to connect this storage with your applications, or you want to access this thing securely somewhere. Now, as you can check here, left side of this section, we have one section which is shared access signature, which is responsible for generating SAS token, SAS tokens for this particular storage, which is somehow going to help me if I want to connect to my blob files, queues and tables securely. Now, I want you to understand this properly, and that's the reason we have created 3 containers with the 3 different access levels: private, blob and container. Now, if I go inside this first container, which is test1, and let's say if I go to container properties, I'll have a full URL of this container. Now I'm going to copy this URL of the container, and in the separate tab, I'm going to try to access that container. And while accessing this thing, because this container can have multiple things, multiple blob files or images inside that, I'm going to give question mark, and then I'm going to give comp equals to list. In short, I'm planning to get a list of records inside that. And when I do this thing, it's saying that the resource not found. For test1 is not allowing me to access anything. Now logically test1 is actually that container which is having a private access, and private access simply means that I am not able to access anything inside this container until unless I provide a valid token or I can authenticate myself. So obviously it's not going to work with this. Let me see test2. So the URL will be similar. Now in this also it's not showing me anything. It is saying that resource not found because the second container is having a access level blob level. So I can get a particular file details, but I cannot get the list of the files because it's having access only up to one particular blob, not for the full container. While the third container is having a container level access. So let me change this URL to test3, and then if I hit enter, you can see it's showing me that the full details of my blob file. And if I have multiple items also into this, it's going to show me multiple blobs in this JSON format right now. I have a full URL of my image available in this. If I copy this and if I paste this thing somewhere in the UI, the container level access is also allowing me particular file access, and I'm able to see the full image in this. So in short, the third level, which is a container level access, is actually something like you are giving a full folder level access into that, and you can have access of all the files into that. If I go inside my second container, which is test2, so let me go inside that. In this I have one image, and let me scroll right side. I have the three dots here. If I click on this, I can go to the properties of this particular blob file. So you can see it's showing me all the properties of this blob file, including that this is a hot image, and then I can just click on this URL, which is going to give me a full URL of that particular image. So I cannot access the list for test2, but if I paste the URL which is coming from test2 and I'm giving a full path of that blob, then it will allow me to access that image. So the second container is not having a container level access, but if you give a access to a particular blob file, then you'll be able to access that. My internet is a bit slow, so that's why it's taking time to load this thing, and even the image is also high quality. So, but anyhow, we have access to this. I hope you understood the two container access, blob level and container level. Private is, as I explained, this is a secure thing. So even if I go inside this container, I can see that we have one image in that, and if I try to get the properties of this image, I'll get the full URL of this image. But this time, even if I copy this full URL and if I try to paste this thing in the browser, it is showing me that I do not have access of this image which is inside test1, because test1 is my container which is private. So the logic says that you cannot access this thing without a proper token. Now how can we use token actually? To understand this thing, in the same page, I am clicking on the tab which is generate SAS. Now this time first I'm trying to generate SAS, and then I can control which kind of token permissions I can choose in this. Let's say I'm saying I'm giving a read access only right now. I can specify a start and end expiry dates with that. I can specify a particular IP address customization so that only these IPs can access that thing. And I can also select the protocols which are accessible in this. I am choosing right now HTTP. And all the SAS token generation is going to happen with your keys which you have given in the storage. And this is a place where your either key 1 or key 2 will be used. Now most of the time I choose a different keys when I have a different environments or different client. Now what I mean by this, if I have two different clients who are accessing my same storage, then I can give key 1 to one client and key 2 to the other client. And let's say if you have two different environments, like one is a testing or staging environment and the other one is your production environment, then also you can use two different keys for both the environments. I'm choosing key 1 right now, and I'm saying generate SAS token and URL. When I do this, below that I am getting a new token which is generated automatically based on the configuration which I have given, and it's also showing me a fully qualified URL which is with token. I'm just going to copy this URL, and now if I try to paste this URL, which is not only a URL but it's also having a token with that, and then you can see that I'm able to access my home sweet home image. So yeah, so this is what a SAS token is all about, and this is what the security associated with the storage. So not only a container level, you have even a file level access also. And now if you understood the SAS token, if I just go back to my storage account, this is my storage account. if I go back to my storage account, this SaaS token or this token-based security is applicable on all four. Now, I'm not showing you the tables, files and all right now, but if I just scroll down to this section which is showing me shared access signature, this one page is allowing you to control which kind of services and which kind of operations you want to restrict in this. Like, let's say if I say that I want to allow blob and queues, not files and tables, and I want to allow access to only Azure services, not any containers and objects, and I want to allow all the permissions except delete permission for this, and the dates are fine, everything else is fine, and I'm saying that this time I want to generate key 2, and if I click on generate SaaS connection string, it's going to show me all 4 different connection strings with a SaaS URL for blob and queues both. So we got a connection string, we got token, we got a URL for blob and queue because we have selected only for blob and queues. Now this URL I can copy and I can give it to my developers team and the testing team, and I can tell them that you can use this thing, and obviously they'll be able to use my storage only within that given configurational tag which I have mentioned in this while generating this particular token. There is another way also to secure this particular storage. You can go to private endpoint connections, as I already discussed while creating the storage, or you can go to firewalls and virtual network, where you can just say that this storage will be accessible only in the selected network, and you can either configure a new network, or if you already have existing network you can add on that into this, or you can fix this thing up to a particular firewall with a specific IP range with that. Now all these ways we can secure our data which is there inside the storage, and do not forget it's V2 storage, so it's by default having encryption enabled in that, which which is visible here in this encryption section, and you can see that it is also having an encryption type which is Microsoft managed keys, or if you want your own customer managed keys you can specify those key URLs into this, which maybe you have generated through Azure Key Vault or some other third-party service, and you can secure your storage with all these options. Okay, so after Azure storage account, it's a time to deal with Azure Cosmos DB. Remember, Azure Cosmos DB, as per definition, Microsoft is saying that it's Microsoft's own multi-model distributed database. And the moment they say multi-model, they actually mean by the different options and the flavors available on Cosmos DB. Also, there is one important word in that, which is distribution. Inside Cosmos DB, we have a facility of turnkey global distribution, which automatically replicates your data to the other Azure data centers across the globe without the need to manually write code or build a replication infrastructure. It has technically something called multi-region write. Normally, if you're using Azure SQL or any other data storage provider or in the database associated with Azure, we mostly have multiple geographical copies from where we can read. But this one is somehow allowing you to deal with this kind of global distributions automatically for read and write both. When we talk about multi-model, we have 5 different APIs available for this. We have a MongoDB API, Table API, Gremlin API for GraphDB, Cassandra API, and SQL API. No matter which particular database platform or programming language you are familiar, we have options for everyone. And when you are choosing Cosmos DB, ultimately it's going to allow you to store everything in a form of JSON files. It is kind of a document DB where you are able to store data in a form of JSON file, and your JSON file is going to have key value pairs. But the way you're going to deal with that is through these APIs. And that's the reason the structure of Cosmos DB is a bit different than other traditional databases. If I focus on the hierarchical structure of this Cosmos DB, then you can understand that first we have a root level, which is a Cosmos DB account. Remember, on your Azure portal also, when you create an Azure Cosmos DB account, then only inside that you can have multiple databases. In each database, we can have multiple collections. Now, it has a different word actually. We can call it collection, we can call it containers, we can also call it graph, and we can also call it table. Now, this level is actually showing you multiple options, or I can say multiple words in that. Depends upon the API which you're using. Like for example, if you're using Grammarly and you're dealing with GraphDB kind of Cosmos DB, then you're going to call that one database will have multiple graph. While in other case, if you're using SQL API, the same thing we call containers, so we'll say that one SQL database will have multiple containers in that. Ultimately, inside this containers, collections or graph, we are going to have multiple items, which will be a JSON document which is going to store data. Also, you can have a facility of triggers, store procedures, and some other user-defined functions with that. Let's see this thing in action. Now, to understand properly, let's see this thing in action in Azure portal. In my Azure portal, I am going to create two Cosmos DB accounts right now. When I click on create resource, we have an option for Azure Cosmos DB. I am creating a new resource group called training RG, and then I'm going to click on OK. In the account name, I am giving Maruti Cosmos DB, and this time I'm going to choose SQL API, so I'm giving SQL 123. You can see we have an option called which kind of API you want to choose. We have core SQL API, we have MongoDB, Cassandra, Azure Table, and Grammarly, which is for graph. I am choosing core SQL API. I do not want to change any of the other options which are there, but in the location we are going to choose East US. Which kind of account you want a production account or you want non-production account? They are giving you option because they are saying in the production account your geo redundancy and your multi-region rights will be enabled. We are choosing non-production account, which is only for learning right now, so we do not want to change anything in this. Let's click on next, which is networking. We will be allowing this thing to all the networks, yes, and then we'll just click on review and create. Just notice one thing, the estimated account creation time which is mentioned here is 11 minutes. And that's the reason in this video, first we are creating two accounts and then I'll show you how you can deal with that. This is a SQL API based account. Let's click on create. Now once this deployment is submitted and it is just processing my first Cosmos DB account, I am going to click on create one more resource in which we will again choose Azure Cosmos DB account. Resource group I'm choosing same, but name of the account I'm giving Maruti Cosmos DB, and this time I am going to select graph. Now I am choosing graph because this time I'm going to use Grammarly API. So in the drop down I'm going to choose Grammarly, which is for the graph DB, and everything else is fine. Region is still going to be East US only, and I'm going to click on next, tags, review and create, and this is also going to take 11 minutes. So I'm going to click on create. Once we have created these two different Cosmos DB accounts, remember this is an account, so as we discussed, inside one account you can have multiple databases. Alright, so now we have two different Azure Cosmos DBs already created for me. You can see both the deployments are succeeded. I am going to click on go to resource in this one, and you can see this is the one which is associated with my SQL API actually. It's directly taking me to quick start of that, but I don't want to go there. I'm just clicking on this overview tab only, and then the other Cosmos DB I want to keep it open in a separate tab. So I'm just opening a new tab, and in this, inside my training RG resource group, I'm going to open my graph DB also. Okay, so both the databases are there, both the Cosmos DBs are there. This is my graph one and this is my SQL one. Okay, now inside this I just want you to understand this thing, that inside the SQL one, first if I click on Data Explorer, this is something like your storage explorer of your Azure storage tables and all. But if I go into this Data Explorer, it is trying to connect with the Cosmos DB right now, and as we know, this is a Cosmos DB account. Inside this account we are going to have multiple databases. When I go into this, this is showing me that it's based on SQL API, and on the top I have options like I can create a new database or I can create a new container. As we know, the hierarchy is like this, that one Cosmos DB account will have multiple databases and one Cosmos DB database is going to have multiple containers in this. Now if I say that I want to create a new database right now, then it's going to ask me what's the name of the database, give me that. Let's say I am specifying some name, and then I have to provide something called throughput. Now this throughput is actually something which is, it's a measurement of your request response when you're dealing with Cosmos DB. Azure actually measure all this thing in the terms called request unit. This is very much similar if you want to compare. In SQL databases we have something called DTU, data transactional units, while in this case we have RUs, which is request unit. This RUs are starting with a range from 400 to 1 lakh requests per second. And this request unit per second is going to give you your throughput. It means your costing of your Cosmos DB account is not based on the account, actually it's based on the database. And in that also, every database can have a different throughput associated with that. And you have to pay hourly based on that. You can see right now they have shown me an estimated spend in US dollars, and it's starting with $0.032 hourly. Now if I just continue this thing, it's going to cost me around $23.04 monthly if I go with the minimum throughput. Let's say if I go with the maximum, or if I change the range to 1000 only, it will reach to $57. And if I go to the maximum, it's going to reach to $5,760 per month. Now obviously we do not need this much higher throughput right now. We can go with 400 also. And the database ID, let's say I am giving a database ID to-do list. The to-do list is the name of my database, and I'm just specifying this thing as a database ID, and then I'm going to click on OK. The moment I do this thing, this is going to add a new database in this Cosmos DB, and now inside this database I can have multiple containers. Okay, my to-do list database is already created. I can see that thing. If I expand this, I have options like scale and all, and if I just refresh it once, you can see that I do not have any options right now. We just have scale 1 option because I do not have any containers in this. Now let me click on new container. It's going to first ask me, do you want to use an existing database? Then you choose from that. Otherwise you can again create a new one. I want to select the to-do list one, which is existing one. What will be the name of the container actually? So I'm giving that the name of the container will be items. Do I need indexing in this? Yes, it's going to automatically index that thing. I'm okay with that. I do not want to specify any partition key right now, but as you can see here, they are saying that the partition key is used to automatically partition the data among multiple servers for scalability. Choose a JSON property name that has a wide range of values and is likely to have an evenly distributed access patterns. That's the reason that partition key, whenever you define, it's going to be something like department or city name or some particular that kind of key which is going to have bunch of data into that. And then it's going to have one partition which will have multiple records into that. Let's say I am giving a partition key is actually name, because inside this maybe we're going to have name associated with that. It is saying that do I need my partition key which is larger than 100 bytes? Now I do not want that. Provision dedicated throughput for this container. We have set 400 as a throughput for this database. Now if I want to provision a dedicated throughput for this container, I can check mark on this, and then I have to specify that particular throughput in that. I do not want that also right now. I'm going to click on OK. Once we're done with this, we will have one database name with the name to-do list, and we'll have one container inside this. This container is having a name items. Now because this is a SQL API, inside this we have something like storage procedures, user defined functions and triggers. And also in this items, this is actually a collection of all the items. I will not have any items right now because it's just now a new container which we have created. But this is a hierarchy which is a Cosmos DB hierarchy for SQL API. Now parallelly, if I just go to my second tab, which is my graph DB, inside this also if I do the same way, click on Data Explorer, it's going to show me that this is a Gremlin API, this is not SQL API. And if I click on this drop down, this is not saying that I have a container. It's saying you can create a new database and you can create a new graph. Now because this is a graph DB, they are treating this thing as a graph, not as a item or as a container. Let me say I want to create a new database. It's going to show me same option which was there. Or this time let's do one thing, let's create a graph with the new database. I'm saying that it's going to have a new database, and I can give a name of the database. Let's say this is my first DB. That's the name of my database, and the throughput for that we are specifying 400. That's fine. And then I can specify a graph ID and partition key. Now this graph ID can be any particular key which you want, and based on that you can associate this. To understand the graph ID and partition key, you actually have to see the code. And that's the reason, in spite of going to this and creating this thing manually, I want you to see that code in the coming video, and then we will see this thing. But we have the same kind of options here. You can specify this, and I can create a new graph also here, but that will not look like a graph. To look that thing as a graph, you need to first add a proper data into this, and that's the reason we will see this Gremlin API with code in coming video. Thank you. Okay, so I'm still with my Cosmos DB, which is based on SQL API. And we know that inside this account, we have one to-do list database of Cosmos DB, and inside that we have a container called items. We still do not have any records inside this, so it's still empty. And now what I want to do is, left side, somewhere inside this Cosmos DB account, we have a section called keys. Like our storage account, these keys are actually, again, nothing but a token. And we have a URI, which is actually a unique URI associated with my Cosmos DB account. I have two different keys available here. We have a read-write keys and we have read-only keys if you want to give access to only read-only things. And in this read-write keys, we have also two keys, primary key and secondary key. So like in storage, you were having key 1 and key 2. Here also we have two different keys. What I'm going to do is, I want to connect this Cosmos DB now with my application code. And we'll see that how we can connect this thing and how we can deal with this to-do list database which we have created inside this account. Now, I have a repository available here, which is on this URL, github.com/trainermaruti/webappcosmos. And I have this project available here. So when you want, you can just fork this repository first, and then you can associate with your account code. In my case, this repository is already available in my Visual Studio. And this is actually a web application, which is a MVC based application. I'm not using .NET code this time. This is pure .NET framework based application. And if you check right now, I have my model in which we have this item.cs. And my goal is, I want to use something like a code first approach, in which I have a couple of JSON properties, which are nothing but C# properties. And using the C# properties, we are going to create a table structure kind of thing. But ultimately, this is not going to be a table. It is going to be stored inside that particular container of my Cosmos DB. We have columns like ID, name, description, and there is a Boolean column also, which is completed. Now we'll check whether the to-do list tasks are completed or not, and then we'll just give a name and description and other properties of that. I have written a logic for this by providing this document DB repository in this, in which I am using the classes which are associated with Azure document DB. Now we have these classes which allows me to write the link queue query and some client-side association with that. So I have written a code in this, and this code is somehow trying to connect with my Cosmos DB account, in which it is looking for an endpoint and authentication key. This endpoint and authentication key is associated in my web config file. And inside this web config file, I have my older account when I have created this particular code. So I'm just going to do one thing. I'll go to my portal. I'll take this new URL of this Cosmos DB and I'll paste it here inside this account. Same way, this key is also older, so we'll not use this key. And in spite of this, I am going to put my primary key. So I'll copy this and I will paste it here in this Visual Studio. Once it is done, I'm just going to click on save. If you want, you can go through this code which I have done inside this. We have items controller and we have done insert and create kind of operations associated with that. Also, somewhere we have a conditions that if any particular to-do list item is completed, then we are not going to display that thing in the UI. And we have created our UI also inside this. So we have some pages index.cs HTML which is displaying all this thing in that. Now to see this thing, let's just quickly run this thing in the local machine first. If I want, I can deploy this thing also on the portal, but now I think you guys are familiar how to deploy this application on Azure portal. So we are not doing that thing right now. I'm just running this thing in my local machine. Yes, my application is running in this local machine, but it's still connected with my Cosmos DB, which is there on portal. So I'm going to click on create new, and let's say the to do task which we are giving is, let's say I am giving prepare for AZ-204, and in the description will say that we will deploy app through Azure CLI, which will do, and this is not completed, so I'll not click on complete. Let's click on create. Let me do one more thing. Let's click on create new. Let's say the second one is call Maruti for help. This is a task, and then you can say that okay, description is hands-on. Maybe you are looking for some extra hands-on, then you can just reach to me for that. I am going to say create. Once these things are done, you can also deal with the edit and details and all this thing, and both are not completed right now. Let's do one thing. Let's quickly check this thing in that portal. So I'm going to Azure Cosmos DB, refreshing this items, and if I do that, I should have some records inside this items actually. Yes, I have 2 records, and if I click on this, I'll be able to see that you can see the first one is prepare for an AZ-204, and the properties which we have is complete is false. The second one is call Maruti for help and then hands-on. Yep, so both the records are inserted successfully. Not only that, this is super quick. If I just, let's say if I click on edit on this, and I'm saying that this is the one which is now completed, I'm going to click on save, and yep, that's not listed here because we did this code inside that if it's completed, I don't want to list it here on the home page. But this record is not deleted, it is actually edited into this. So if I just refresh this, and if I refresh it here also, I will get that this call Maruti is having is complete true. So in short, like a normal database table, your create, insert, update, delete kind of operations, it will work with this. In short, all your CRUD operations, create, read, update, delete operations will work very easily, and because you have higher throughput now, performance wise also, Cosmos DB will be much better. Okay, so now we are inside our Cosmos DB, which is actually associated with the Gremlin API, so it's a graph DB. I still do not have anything inside this data explorer, as we have seen in the earlier videos that we have not created any graph inside this. Now to deal with this, I'm just clicking on quick start. This quick start has given me 3 different options available here. In that, the first one is actually based on the .NET, and they are saying that if you want to deal with this graph DB, and if you want to see how this Gremlin API is allowing you to access data and store data and all the thing, you can just do this thing in this first 2 steps. The first step is actually adding a graph, so you can click on this create a person's container. The moment I do this thing, it's going to create a new container for me, and it's going to create one new graph DB also for me. Now once this process is done, it will generate one application which is automatically going to have association with this Cosmos DB account. Now you can see that the first step is already done. The second step is showing that I can download this particular application in my machine. So I'm going to click on download, and it's downloading one zip file into this. We'll open this thing very soon. But before that, let's click on this Open Data Explorer. When we do this, it's going to show me that it is going to have a graph DB which is already created, inside which I have one person's graph. And then inside that, if I click on graph, I still do not have any data actually. If I click on execute Gremlin query, which is showing something like this, I do not have anything inside that. Yep. So this is a graph DB, but I seriously do not have anything inside this. Now let's understand how graph DB is actually creating structure and how it's storing data. And to do that thing, we actually have to understand the sample. Now before we go into that application code which we have downloaded, I want you to understand 3 different terms so that you can understand this graph properly. Remember, a graph which we are discussing right now, or the graph DB which we are discussing right now, is actually nothing but a structure that's composed of two things, which is known as vertices and edges. Now in this case, this is not that graph which you are maybe visualizing like a bar chart or a line chart kind of thing. This is actually combination of vertices and edges. Now what is a vertex? A vertex denotes discrete objects such as a person, a place, or an event. And then edge denotes a relationship between vertices. Now logically, graph is a relational database without a foreign key primary key kind of structure. This graph DB allows you to store a discrete relationship between two different objects. Let's say if I tell you that if you take any two person, like I am one person and you are the other person, and if I want to find out a common things between you and me, maybe we both belongs to different countries, maybe we both belongs to different professions, maybe we both have a different characteristics, but still there are certain things which are common which we want to find out, then maybe we can find out that we both have a common interest, which is Azure. Now when we do this thing, we both are actually vertices, and the common edge which is connecting and showing me the relationship between you and me is maybe Azure. Same way, a person or a place can be a vertex, and the property which are associated with that, which is known as edge. So for example, a person might know another person, that is also something which is known as edge. Maybe we both do not know each other, but we both have visited a same restaurant on a different time, and we both have reviewed that same restaurant. That is also something which is an edge, a relationship between these two people. This kind of relationship are mostly useful when you are developing an application which is either e-commerce or mostly social media. If you are familiar with websites like Facebook and LinkedIn and all, they always relate one user with other user. Like in your LinkedIn, you have your first connection, second connection, third connection kind of thing. Or maybe this is also something which you can use when you're dealing with the e-commerce site like Amazon.in, and when your user is buying one product, you want to relate multiple products with that, and you just want to give some suggestions to him. Cosmos DB is going to be widely useful in this kind of cases. Now it's the time we need to see that code, so let's go through that. That application is open in my Visual Studio right now, and it's a very simple console application which is just having one C# class called program.cs. If I go inside this, I have some properties which are allowing me to connect with my Cosmos DB account with the authentication key. This part I have not done, or also I have not copy pasted this key. It automatically got generated because I have clicked on those buttons in the quick start in my Azure portal. It is connected with the database called GraphDB, and inside that is connected with the collection called persons. Now I know maybe you have never dealt with Gremlin API and you have maybe never used it in your past. But still, as a developer, I'm sure you are able to understand this code which I'm showing you. If you check right now, we have G, which is a global variable created with Gremlin, and then we are calling couple of predefined functions with that. The V function is for vertex, and the E function is actually for edges. Same way, using that, we have a function for properties also, which is associated with maybe a vertex or an edge. Using this, they are trying to write some logical data inside this GraphDB, and they are specifying first whatever is there, we are going to drop that. Then we are trying to add a new person with the ID property called Thomas, and he has a first name as Thomas, and his age is 44. It means first we are adding one vertex. Then we are adding one more vertex with the different values inside that. Her name is Mary and the last name is Anderson, and she is 39 years old. Same way, we have two more person. Then we are adding an age between two persons. So we are saying G.V, which is a Thomas, and then we are adding an age which is nose, and we are specifying another G.V which is Mary. So we are saying that Thomas knows Mary. Same way, Thomas knows Ben. Now Ben do not know Mary, but Ben knows another person who's known as Robin. Logically, when we do this kind of things, this is adding a relationship between one vertex and the other vertex, and then it's actually going to build up a graph. That's the basic reason this thing is known as GraphDB. Same way, we have couple of other properties in which they are just trying to connect all this thing. Somewhere in this logical queries, the last lines are actually some dropping something. They are actually dropping all the vertices and all. Let me do one thing. I just actually want to remove this first two lines. So I'm just going to comment these two lines because I do not want to drop anything. Even there is a drop age for this Thomas also. I do not want this also. So I'm going to comment this last 3 lines from the bottom. And then now let's try to run this thing. It's a console application, so it's just going to execute this code line by line. And maybe it's going to create all the vertex and edges and all the thing with that. Once this code is done, I want to see whether the data which is there in my Cosmos DB is looking like a graph or not. Yes, the code is executed, is showing me press any key to exit. I do not want to press any key. I want to quickly switch to my portal. If I go there, if I refresh this Gremlin API, it's trying to fetch containers in this. And now we have a person's collection into this. We have a graph inside that. And I want to again click on this button which is execute Gremlin query. You can see it's showing me that I have 4 vertices available in this: Thomas, Mary, Ben and Robin, and we have properties associated with each and every user. So we have a properties associated with each and every vertex actually. If I click on this, and now if I just try to show you this section which is a graph, you can see that it's showing me that we have a connection between Thomas and Ben and Thomas and Mary. And then if I click on Ben, it's showing me further details about that Ben is also having some other properties and other associations. Maybe Ben knows another person is Robin. And this full graph is actually created using that particular JSON document which is associated with this thing. If I want to see the JSON data, I can do that also, I can see that also. Or in this, if I want to change the style of this, or if I want to add a new vertex directly from this, that also is possible in this portal. I hope you're getting a basic idea about GraphDB and Cosmos DB also. Thank you. Hey friends, I hope you have enjoyed this course so far, and as per the new guidelines given by Udemy, as you can see on screen, now starting from March 17th onwards, any of the free courses which we are publishing on udemy.com as an instructor, we are not allowed to put more than 2 hours of video content in that. Now that's the reason in this particular video course we are not able to share all the modules to you. But you do not have to worry about this thing. If you really like this course and if you like the way we are teaching you this particular video series and the technical concepts inside that, then you can go through our official site which is mentestech.com, and when you go there you'll have lots of premium content available with free of cost. You just have to sign up there as a member. So without wasting time, just go there and register yourself there. Also, do not forget to sign up our newsletter to get the new updated content every week. As of now, this is a goodbye from me, Maruti Makwana, and I want you to make yourself future ready. Happy learning. Take care.